Hello, everyone. It's a beautiful season, and it's quite a sunny day here in Lagos with a temperature of about 31 degrees. So uh, this is another exciting way to make today even better. So welcome to the stage F Open Source Project presentation. I want in a very special way welcome our judges, members of the IMOA team, and all our interns joining this call from different parts of the world. It's a pleasure to finally meet us this afternoon. So I'm sure a lot of things have happened between the last time and now, and I think it will be quite exciting to hear a couple of them from all of us. But then, because we of the constraint of time, we'll just speak with a couple of interns. Want to speak with Emmanuel Ogunwede, who's currently on the call. Emmanuel Ogunwede was he scored the highest. He had the highest score in terms of quality of presentation at the Stage E Open Source project, and he's here to share his thoughts. I also have Chigozie Umbono. Chigozie was the query analyst for the team that won at the Stage E. So we'll have them share their thoughts with us in a couple of seconds, and then we'll proceed on to the presentation proper. So, hi, Emmanuel.
Good afternoon.
Yes, good afternoon, Emmanuel. It's good to see you again here at the presentation. So what was the feeling like between that time and now? Single, highest score you had, and then I think you did a great job. So what are you expecting from this presentation today?
Thank you. Well, I think the first challenge for today's presentation is time. 2 minutes is really short, and you have to just beat all the stories and put it out, and then just focus on helping the judges understand what exactly it is you try to achieve with your project. So I think it will be really tricky, but then I look forward to a good presentation.
Yeah, thank you very much. It looks forward to a really good presentation. Let's hear the thoughts of Chigozie Umbonu. Hi, Chigozie.
Hello.
Sorry. Yeah, I'm sure you want to repeat the feat of Stage E where you became champion. So how was the preparation be like?
It's been massive. It's been massive. We've been on our toes since like day one. Even when they gave the extension to 5 weeks, we were still on our toes. We've been preparing for this, and you can never really be too prepared. Oh, sorry about that.
Okay, so it means that you are more than ready for this presentation, and then you look forward to beating Emmanuel's record.
We have done our best. So we've done our best. So let's just see how it goes. Let's see how it goes. You can never be too prepared for anything. So, but we've done our part.
All right. Thank you very much, Chigozie. Thank you, Emmanuel, for the feedbacks. But we don't have so much time on our hands, just like Emmanuel said, and then we'll proceed. Our very own program manager, Femi Uyinowo, will give us a few housekeeping rules and then introduce our judges, and then we'll proceed from there. Thank you, guys. Femi.
Thank you very much, Emmanuel. Very good to see everyone this afternoon. It's a sunny afternoon right here in Lagos, Nigeria, as Emmanuel rightly said, and I'm much more delighted to be seeing you. So today is the Stage F of the Open Source projects, the presentations for the Stage F of the Open Source project, and hearing Chigozie Umbono speak and hearing Emmanuel Ogunwede speak, I'm excited as to what these presentations hold. As Emmanuel already put, tricky, and Chigozie added preparation. So let's see I would love to see how much time has been put into preparation and how each group is able to circumvent the trickiness that this stage will bring with it. So at this point, I'll just go over a few housekeeping rules and then we start. So today we have 16 groups presenting. Each group will have 2 minutes each for their presentation. All groups will be judged by 3 judges. The judging criterion will be based on the quality of solution, methodology, and quality of presentation. After each presentation, our judges may ask any questions of the presenters, and feedbacks will come later at the end of the presentations. So please take note, you have 2 minutes, and at the 30 seconds mark, my colleague, Emmanuel, who is the moderator for today, will be telling you you have 30 seconds and you're expected to wrap up. So now let's move on to meeting our judges. So our first judge today is Charles Adetiloye. Charles Adetiloye is the founder of Maven Code. He has over a decade worth of experience consulting and implementing large-scale data computing platforms. And it is good to have Charles here with us again today. Our second speaker is Wale Akifaderi. Wale is a data scientist at Amazon Web Services and also a member of the Google Developer Expert Program in machine learning. He has broad experience in implementing and extending machine learning techniques to solve practical and business problems. And finally, our third judge for today is Biodun Awujobi. Biodun is a customer engineer at Google. He's a creative technology architect, a cloud security leader, and an accomplished scholar. His strengths include, but are not limited to, business development and cloud computing. Now, you've seen and heard our delectable judges speak at previous times and at previous webinars. Their eloquence, their mannerisms, and intellectual acuity has been on display for all to see. Well, today, I'm glad to announce to you that it's your time. The stage is set and the mic is in your hand. So the next voice you'll be hearing is that of the first presenter from Group 1, Precious Ulrika. Precious, over to you.
Can you hear me? Hello.
Yes, I
can you hear me?
Yes, we can. Please proceed.
Okay. Good afternoon, everybody. Okay. Let me share my screen. Can we see my screen? Sorry.
Yes, we can now. Please proceed.
Okay. Good afternoon, everybody. My name is Precious Ulrika, and I'm representing my group, Road Safety in the UK. I have some wonderful contributors to this project. Problem statement. Are there patterns for accidents involving different road users? Can we predict the safest and most dangerous times to travel? Can this data help route cyclists around accident hotspots, take into account the time of the day, setting cars more accident prone than others? So these were the existing solutions done by the previous group. So we moved forward with it, and our approach will be carrying out an exploratory data analysis that involves time series analysis and geospatial analysis, as well as correlation analysis. The data descriptions, we had about 5 data sets to work with. The first one was for the problem statement for certain cars more prone to accidents. So from these charts, we're able to analyze from 202 different car brands. We're able to make use of over 1% representation, and we made use, and we got some data that showed how Ford and Vauxhall, which is a product of Opel, were the most prone cars. Then we carried out a geospatial analysis. For this geospatial analysis, we were able to determine accident hotspots that will help cyclists navigate around accident-prone areas using an interactive map. If time will be given to me later on, I would like to come back here to carry out a practical analysis. Then we carried out a time. Okay, we carried out a time series model from the previous work done by the group, where recommendations were made, and we were able to determine the trends, the time of the day, the months of the day that had high casualties and high accident rates. So we were able to make predictions, future predictions from the previous training data, able to make predictions of the months that will have high casualty cases as well. So we carried out, we did a pipeline for it, and our summary, in general, we were able to analyze relevant trends that would enable authorities. Yeah, we're able to analyze trends that will enable authorities to plan ahead in order to reduce road accident casualties. So from this study, we believe that road safety authorities will be able to make use of these trends to reduce the risks of accidents. Thank you.
Thank you, Precious.
Yes.
Thank you, Precious. Our judges.
Yes.
Yeah, quick one. This is Charles. Can you go back to where you have the time series data? I mean, the time series plot, where you have the prediction. No, the next one. Yeah, that one. Yeah. So I assume like the blue line was the real data and your prediction was the orange plot. Can you explain it?
The orange, yes, sir.
Can you explain? Just zoom in a little bit on Can you explain the plot again?
Is it clearer?
The casualties versus the I'm sorry. When I said zoom in, sorry, it's in the context of your presentation. Can you explain how the model you used for this and how you came up by your like that?
Okay, we carried out a univariate a model using Prophet. We carried out the Prophet model using for univariate time series to forecast the accident casualties, where we trained our data using the first 12 months, and we made a testing for future predictions or forecasts for the next 4 months. So from this, we're able to from our model in our repository, there's another line, a very light blue line that showed the upper and lower boundaries. So it was able to gather these blue lines that are extended. So the brown line we could see right now is the predictions for future forecast.
Okay. So
and we compared.
Let me just pass my comment real quick. So so I have two questions to follow up with. Why Prophet over every other modeling that you can have used like ARIMA or LSTM? What's the advantage of Prophet, which I think it's from Facebook? Then the other thing is it looks like the real value and the predictive value, the thresholds, like the range are a little bit different. Why is it not tracking close enough? And things like that. So those are like my three questions, but you can just answer it. I don't want to take too much time.
Okay. For the second question, why do we know tracking was because we made use of a univariate time series. We believe the addition of more regression or more features would have be able to train the data more. So that was why, because we actually carried out a multivariate time series and it actually was able to train better than this. But because of our problem statements, we had to restrict it to the number of casualties. So we made use of a univariate time series.
Okay.
Yep.
And why did you use Prophet over, let's say, LSTM or like ARIMA time?
The basic reason why we carried out Prophet was because it was faster and it was easier to implement. It was faster and easier to implement. That was the basic reason.
Okay. Then I'm going to ask you my last question, and I can yield to like the other guys. If you go to slide 11, I just want to see your pipeline implementation.
Okay, sir.
So you create a volume, you pre-process, you train, and you predict. Can you talk a little bit about the pre-processing stage what you did? And if you can you post a link to that pipeline in the Zoom once you're done? Not right now. I just want to see the pipeline if you have it publicly in the Git repo. Can you talk a little bit about the pre-processing?
Yeah, we have it in Git repo.
Okay. Yeah. Okay. So can you just explain the pre-processing real quick? Hello? You're breaking up.
Hello?
Is it me or? Hello? Hello?
Hello, can you hear me?
I can hear you.
Hello?
Hello?
Precious, we can hear you. Go on, Precious.
We can hear you. Just send the link on the Git and I'll just
so you said.
Yeah. I was asking about the pre-processing, but I don't want to take too much time. Send me the Git link and I'll follow up with you. All right.
I can't hear what he's saying. I think it's from my. Hello?
Send me the Git URL. Yeah.
Okay, so Precious, what I was asking you to do is to send the Git URL. Is that noted, Precious?
Okay.
We'll move now on to the second group for the day.
Okay, yes. Okay.
Yeah.
I should send the Git repo. Was that what was said? Sorry.
Yeah.
Hello?
Yeah, that's what I said.
Yes.
Yeah.
Okay. All right, I'll do that now.
So thank you, Precious. Thank you for your presentation.
Thank you.
Sorry, before I call on the next group, I don't know if Wally or Building has anything to say or ask.
No, we can go to the next one.
All right, thank you. So the next group for today is school progress, and the presenter is Habib Agbaje.
Hello, good afternoon.
Good afternoon, Habib.
Okay, so can you see my screen now? Is everybody seeing my screen now?
Yes, we can see your screen. Please proceed.
Okay, good afternoon, everyone. My name is Habibullah Agbaje, and I'll be presenting for my group 2, which is titled School Progress. And here are my group members. So education is a very important sector to any government. So with this project, we aim to highlight the strengths and weaknesses of the Indian educational system through its facilities in different levels of education. To carry out this analysis, we are provided with 7 datasets from the 2013-14 to the 2015-16 sessions. We decided to approach this as a storytelling project because of the small amount of data. So get ready for a myriad of charts. Now, before the visualizations, we did some data cleaning and preprocessing, changing some object types to numerical formats, replacing the NR values with none and dropping some, and changing the name of the states that were input wrongly. So we'll go through the data sets one by one, but due to the time, I'll have to skip some slides and I might be talking a bit fast. So for the gross enrollment, we can see that it was actually really impressive as it generally increased over the years, and the ratio between that of girls and boys was pretty even. The state with the highest enrollment was Delhi, and the lowest was Jammu and Kashmir. These are some waffle charts showing the enrollment across the 3 years for the 4 levels of education. These are some Chloripert maps for the 3 years. And our APL was able to source for some extra data, which showed that there was a high correlation between gross enrollment and the literacy rate. We also noticed something. The gross enrollment reduced as the school level increased, which we found out was due to the fact that education is free and compulsory in India till the age of 14.
I think you have 30 seconds more.
So for the dropout rates, we had the highest was Chandigarh and the highest was Nagaland and the lowest was Chandigarh. There was a steady increase. For that, the electricity too had a steady increase, and there was a general steady increase amongst all the facilities. So we tried to do a model also, and there was very little correlation between the facilities and the gross enrollment, but there was a slight inverse correlation between it and the dropout ratio. So, but the scores that we got from them were really low. So we decided that
please round up in 10 seconds.
Pipeline. Yeah, so that is it. We didn't do a pipeline because of the data was not enough because it was just 3 years. So the summary is that the facilities increased over the 3 years, but the dropout ratio actually increased also, which was not actually that good. But the gross enrollment increased.
Thank you, Habib. Thank you for that presentation. Yes, to our judges now.
Hi, Habib. So what's the take home from the project? And okay, you can go on. You can answer that.
Okay, the take from the project is that there's different facilities that generally most of the facilities increased over the years. There were only like some particular states that had issues or some particular school levels that had issues. Like for the electricity, the school level, the primary school level, the primary and upper primary had issues that were below 50%, unlike the other places that were above 70%, and maybe the toilet facilities increased actually for the secondary and this is. So generally it all increased. The only main issue was just the dropout ratio, which increased, sorry. It increased over the 3 years, which instead it was supposed to reduce. So that's our main take from the whole this thing. We weren't able to create a good model because of the data was not enough. We only had data for 3 years.
Okay. Sorry, just to follow up. If you guys had more time, what do you think you'd have done better?
If we had more time, as in for the presentation or for the whole project?
Yeah, more time for the project and more time to get data, whatever. Yeah.
If we had more time, I believe we would have been able to maybe get more insights into the individual facilities and definitely get a better model.
Okay, sure. Thanks.
Thank you.
I'll let the second presenter go and I'll comment on that one to save time. Well, good job.
Okay, thank you.
All right, thank you, our judges. Thank you, Abib, for that. So we'll move on to the next group, restaurant sales. Our restaurant sales is represented by Iwozo John and Oluwatosin Olajide.
Good afternoon, everyone. Can you see my screen?
Good afternoon, John. We can see your screen. Please proceed.
Good everyone. My name is Iwozo John, and my team worked on a restaurant revenue data set from Kagi where we're required to predict the annual revenue that will be made by potential restaurants. Now, this prediction will help the company, that is Start Food Investments, to make wise investment decisions when opening new restaurants. Our main task consists of analyzing the data and building the regression models for accurate decisions. To start with, we carried out some necessary EDA. We did some future engineering to boost the model predictive power. During the EDA, we also observed that we had a lot of data from Istanbul, the capital of Turkey, which is expected since it is a major city in Turkey. These are some examples of the EDA that were done. Then we also carry out some future engineering. These are the steps we carry out from future engineering to because our training data was small, so they had to carry out some future engineering so that we can help boost our model accuracy. We built different regression models and ended up with XGBoost, emerging as the best, with a RMSE score of about 1.74 million. So very close to the winner score of 1.72 million. We're able to improve the RMSE score of the previous group by having a significant 25.5% decrease in their score. And our score would have placed us at the 5th position of the Kaggle leaderboard if it were to be updated. We also observed that the training data was very small, about 137 samples, compared to the test data, about 100,000 samples. That is, the test data was about 730 times bigger than the training data set, and this was a challenge. Some
John,
of the majority of the features were also obfuscated form. We recommend that more training data should be provided, and the obfuscated features should also be made clearer to help improve the model accuracy. And we also recommend that based on analysis, Izmir, that is a major city in Turkey, is actually a good location for restaurant business because it has relatively high revenue, second to Istanbul. Thank you.
Thank you, John. Our judges now.
All right, so based on the data that you got, what would you say your general summary is? Because I wasn't sure if I got that right.
Well, our problem statement was building a model to be able to predict the revenue of restaurants. So we're able to build that model.
Okay, and so based on your observation, you're saying that you had very little entry, so you really weren't able to complete the model. Is that correct?
We had very little entries, about 137 samples. So it was a challenge because we had so many. The test data set was very big and the training data set was very small. So the predictions, it was very easy to overfit or underfit the set.
Okay. Could you maybe summarize your learnings then?
We're able to build the model, and we achieved a very low RMSE score, and that was actually just the main task.
Okay.
We're able to cope with the data and be able to do something great with it.
Okay. All right. Well, that's all that I have. I don't want to spend too much time.
Yeah. I mean, my only comment or maybe suggestion is whenever you're presenting, I think you want to put more life to your presentation so that it stands out and it's a lot more visual. Yeah, you don't have enough time to like run through this. So, but there's a lot of text and verbiage. So people won't read it, but people see pictures and they connect with it a lot more than just text, because it's a lot of cognitive load to like process all those things and read it. So if you want to tell your story and you want people to listen to you very well, you want to make it very visual.
Thank you, sir.
Yeah.
Okay, thank you. Thank you, our judges. Thank you, John. For that, so we'll move on to the next one, Hotel Review Group, and that will be represented by Tohib Olayemi and Tolu Olorunishola.
Good afternoon, everyone.
Good afternoon, Tohib. We can hear you. We can see your screen. Please proceed.
So I'll be talking about the hotel recommender systems for hotels in Europe. Our problem statement was we had an issue to build a web app that uses machine learning to predict hotels for users in the UK. So based on what the previous group have done, they've done exploratory data analysis as they cleaned the data to build a recommender machine based on 3 different scenarios. So working from there, we built a web app using the Flask framework, which uses the Picoot file for the model to predict hotels for users. So instead of people actually seeing code, they can see what the code is doing in real life. So we were able to build a 2-page, 3-page recommender machine. The first one says it's just the home page for the prediction. The second page is a form that takes in the details of the user, which supplies it to the Picoot file on the back end, which then recommends hotel for them. One of the challenges we faced during this process is that the way the model was built previously by the previous group, it was unable to be Picoot because they built their model using a class. So we had issues taking our model to the back end of our Flask framework. So in conclusion, we were able to make a discovery that whenever models are used during machine learning and they are built from scratch and not from sklearn, they cannot be Picoot. And upon further research, we were able to find out what was called Cloud Picoot, which as at this time doesn't have a documentation yet. So we were unable to take our Picoot file to the back end of our web app. Thank you.
Thank you, Tohib. That was quite a fast one. You ended up in 1 minute, 30 seconds. So now to our judges.
Can you talk a little bit more about the training? It seems as if you just took the model and you have an input and you're using it. Can you tell us about how you did the training and everything around it?
Sorry, I didn't get your question, sir.
How did you do the training, the model training?
Oh, so we proceeded from where the previous group stopped from. The previous group had already created a model which we tested in their file for recommendations, and it worked quite all right. So we Picoot the model because they use a Python class for preparing it. We Picoot the model and use the Picoot file for the backend of our web app. So our web app uses a form that takes the details of users, takes it to the backend, but we are supposed to use the Picoot file of the recommender machine to make predictions to the users.
So your work was very easy. You just had to build a wrap around the Picoot file?
Yes. Yes.
All right. Okay.
Okay, thank you, Charles. I don't know if Wally or Building has anything to say to.
Nothing from me.
Oh, okay. Yeah, I didn't unmute. So what was the model?
So the model was there are 3 recommender machines were built. One recommends to people based on the tags. For example, if they wanted an hotel with, let's say, a good restaurant.
No, my question was that what was the model behind the recommender machine?
The model was built from. I'm not sure I quite understand the question, but The model was built using a Python class from scratch. It uses machine learning, natural language processing for cleaning the data, and I don't know.
Okay, yeah. The reason why I said is that the methodology wasn't exactly clear. I just said you guys did a recommender machine, right? But in the recommendation systems, there are what tens of different kind of machine learning models that you can use. Code stats, conditional random field. There are just so many of them, so I wasn't sure what exactly you guys used.
Okay, now I understand your question. Basically, we worked on what the previous group had done, but what we had was a recommender machine and a pcode file. But we were not the one who built the machine. We were only working with what has been built.
Okay, to build an app. Okay, all right.
Yeah.
Thanks.
Okay, thank you, Wale. Thank you, Toyib, too. We'll move on to the next one, electric power, and that will be represented by Ome Chukwu Emeka and Kenichi Ojukwu. Ome Chukwu. Kenichi, are you ready? Please proceed.
All right, please give me a second. Hello, can you hear me?
Yes, Kenichi, we can hear you. Don't start sharing your screen yet.
Okay. Okay. All right. So, where's Charles? Chris, are you online?
I'm online.
All right. So, hello, Chris. You can go ahead now. Hello, Chris.
Okay, good afternoon, everyone. I'm Chukwuemeka on behalf of Group 5, Electric Power. Our project was measurement of household electric power consumption.
Chris, can you increase your volume? We can barely hear you.
Okay, good afternoon, everyone. My name is Chukwuemeka Christian. I'm representing Group 5, measurement of electric power consumption. Next slide, please. This is our team. The team is made up of data scientists and data engineers. Our statement is talking about how can we be able to measure electric power consumption so that we can be able to know the appliances in our various households that contribute to the energy, the power consumption we get from our electric distribution companies over time. Next, please. So our existing solution has been, we always use meters to measure electric power consumption by maybe using meters like multimeters to measure multi-few. So in our data set, there are some meter that we are used to measure some of the parameters. Like submeter 1 was used to measure energy consumption in kitchen. Then submeter 2 was used to measure energy consumption in the laundry room. Submeter 3 was used to measure energy consumption like electric water heater and air condition. Next.
Yeah, Chris, okay. You have 30 seconds more, please.
Please, can you move on? Go next, please. So our data set is made up of over 2 million entries with some floats and integer types. It's been a time series data set. We decided to go do some analysis on it. And the plot of the analysis showed that some of the data sets are skewed and some others are fairly distributed. Our decomposition plot so that there are some cycles in data sets, meaning that there are trends and signalities in the time series data set. So our active power analysis shows that there are high active power consumption in the year 2007, followed by 2009 with 25.2%. Next, please. Next. So the summary of data set shows that data set coming from France, being a temperate region, there is high power consumption in the winter season because the winter they use monthly heaters to heat up the room because of cold, and there's low power consumption during the summer season, which is hot period. So we also observe that there in the first quarter of the year there is high power consumption compared to the last quarter, and the first quarter is basically from December to February, which represents the winter period when there is cold and there's need for heat to be generated in the home, in the household, so that the heater can be able to give heat to the household people. So there is also high power consumption.
10 seconds, please.
So in the weekends, being Saturday and Sundays. So the reason being because in the weekends there are no much economic activities happening, and these contribute to high power consumption in the household. Our best performing model was LSTM. Thank you.
Thank you, Chris. Thank you so much, Chris. So, judges, over to you.
So, you can go ahead, Josh.
Oh, sure. Okay.
Good.
Yeah. Okay. Thanks. Yeah. So can you flip it to like the slide where you have the Keyflow component again? I'll just keep it short so that Wally can take it over. Can you? Yeah. I just want to make sure that whenever we're doing this thing, it's done correctly and we're not just creating a diagram to make things very fancy. So can you explain what's going on in step?
Okay. In our Keyflow component.
No, let me land. Can you explain what's happening in like you have the data volume connected to data processing and the third to the last step. Can you explain why you need that and what was going on? The pipeline kind of, yeah, the data pre-processing, because everything kind of look like it's the same thing recursively.
Okay, the data pre-processing we performed. We standardize the data, that is normalization. We use minimal scalar to perform some normalization on the data sets. Because our model being LSTM, which is a current neural network, is used to normalize the data so that the value can range, our value range between 0 and 1. So that was why we use minimal scalar to normalize the data set. That's what happened in pre-processing stage. So that our LSTM can be able to understand it easily instead of just using it without pre-processing on it.
So what's the dependency between that and the previous stage where you're doing, sorry, I can barely see it, stationary check?
Okay, the essence of the stationary check is because it's a time series data set. So we need to understand whether the data set is stationary, which means whether there is any seasonal effect, trend effect, cycle effect. So when we do that in that particular component of the pipeline, there is like an if-else statement that checks. So if it is stationary, then it will go back to the next. It will go to the next component. If it's not stationary, then we decompose the data set to make sure that it's stationary before it goes down to the next step. So that is the essence of the stationary check.
So when you say go to the next step, are you saying going to the next component?
Yes, next component. Next component.
Yeah, I'll probably need more details on that. I don't want to hold up this call, but just wondering how that will happen, because the other thing I was going to ask is like, so why do you need to input from the original data sets if you're taking an input from the stationary check state and passing it to the next state? We can take it offline. What? Yeah, go ahead. Yeah.
Okay, the stationary check, the real essence of it just for you to know whether the data set is stationary or not, because we are doing a time series modeling. So if we model it without checking whether it's stationary or not, it's going to affect our predictions.
Okay. And are you checking row by row, line item by line item, or you're doing it in a batch? And you're getting the output of a batch.
Okay, we use augmented declarative test. That's what we perform there. Is a function in the start module of Python start module library. So that particular function, what it does, it picks the whole data set, the particular one you analyze, because we did a univariate time series analysis, so which is active power consumption. So when it takes the active power consumption across the whole entry, it will perform this stationary test on it. So it uses the P values, which is the significant value, and some critical values. So when the significant value, which is 0.05, the stationary test result, if it's lower than the significant value, we tend to say that the data set is stationary. But if it's greater than significant value of 0.05, it now becomes non-stationary. Then you need to decompose it to make it stationary first before we get into modeling.
Okay. Do me a favor, just send me a link to the pipeline Git. I think I don't want to take too much time from this, but thanks for the explanation. Send me the link to the Git, and I'll just read through and follow up back with you if I have more questions.
Okay.
Yeah, I can quickly. So my question is that this is the same data from the module, is it the stage 5 of the data science, right?
Yes, sir.
Okay, because what I don't understand is that we had this data in stage 5 that you guys had to walk through, for 3 weeks. And then even in the last presentation also, someone presented on this same data. So I don't know why it just keeps recurring. Why? I mean, there's so many open source projects. So
it was what given to us by Harmony team. So they say we should just see how we can improve on the previous work done by other group. And I believe it's got across every other group. They were just working on previous stage work.
Okay, but you guys are doing just univariate. You did not do a multivariate time series.
No, we did univariate data because the project statement says we should measure the electric power consumption. So we focused on the active power consumption. So we didn't perform any multivariate analysis.
Yeah, so when I say multivariate, is that where you're using, from your model, you were using other features as regressor. So you were using the submeter in 1, 2, 3, right? Or you didn't use it at all?
We use the submeter for analysis check. So we didn't use it in the modeling aspect.
Okay, you didn't use it in the modeling aspect. All right, sure.
Okay, thank you very much. Jojo, any comments? Any questions?
No comments for me.
Okay, thank you very much. Thank you very much, Chris. And
thank you.
We'll move into the next group, which is wine tasting, and they'll be represented by Jolomi Tosanwumi and Joseph Olaide. And so very quickly, before Jolomi and Olaide go on, please, if you are presenting, please make sure that you are prepared before your time so that you don't have issues sharing your screen, and only the names given to us for presentations will be allowed to present. Thank you. So Tosan, Wumi, Jolomi, over to you. Jolomi, are you there?
Hello, can you hear me?
Yes, I can.
Okay, all right. Let me start sharing my screen. All right, can you see my screen?
Hello? Yes, I can see your screen. Yes, I can see your screen. Please go on. You have 2 minutes.
Okay, good day, everyone. We are the wine tasting group and we work on predicting wine varieties. These are our team members. Our project is just to survey the world's most difficult examination, which is the Master Sommelier examination. And this is our approach. Our data comes in pass through some pre-processing. We blended CNN and LSTM using MLP model. These are the features in our data set. The ones highlighted in red are those that show signal. The wine varieties are target variable. Our data had over 707 unique varieties, but we work with the top 20. And this graph shows the trade-off, how we came to conclude to working with the top 20 because it covers 72% of the data set. Because most of our variables, most of the variety have just one observation. And then for the top 20, we have to oversample the minority class by using sentences as documented result of the whole review. So CNN gave a FR score of 0.85, log short-term memory 0.87. When we blended both of them, we saw an increase by 0.7. By 0.03. So we created a web app, and then this is the app. We're just going to do some kind of testing for the app now. So while that is running, I will continue my presentation here. So some of our limitation we have is that there was were limited to predictably top 20 variety because of the imbalance in data set and limited GPU allocation. Business value, it can make people to prepare for the Master Sommelier exam where people can come to our app and then use our app to test and prepare better for the exam. It can help wine enthusiast company like Wine Review to improve on their staff
And then our summary is that our CNN and LSTM model indeed perform like a master sommelier. Currently, we have only 269 master sommelier in the world, and in the world multiple example, our model was able to perform very well with a F1 score of 0.79, 0.879. Thank you. Hello.
Yeah, thank you, Jolomi.
Yeah, so this is the prediction from our model. Is he predicted this wine variety. So let's go back to my slide. All right, thank you.
All right, thank you, Jolomi. We hand over now to the judges.
Yeah, let me just chime in real quick. One quick thing about the presentations is like, man, you can make your slide a little bit more appealing next time. Okay. The color combinations and everything, they look off key. So, I mean, when people see things you do, you want to create an impression and you want that to stay with them so that if they see you a long time from now, they may not remember you, but they remember what you did. And it's very important. So the color combination just looks a little bit off to me. But go back to the Keyflow pipeline. Did you guys actually build a Keyflow pipeline?
Yes, we did. Yeah. That is it.
Yeah, a web app was also created. So I'm just trying to understand this in relation to the web app. So you trained the model, you did the prediction. Well, where did you get a model and how did you put the model into Flask and deployed it in Heroku?
Yes, we for the deployment with Heroku, we use deal to Pico our fitted model. So that's what we used to deploy to our Heroku.
I'm just trying to connect the two. So you have a pipeline that trains a model and you print the prediction. Well, yes. How did you get the output of the pipeline and put it in Heroku or wrapped it up around your web app?
Okay, yes, we did connect our pipeline with our web app because data engineering, we have some kind of difficulty in the deploying with the Keyflow. So we just build this Keyflow for experimentation. So for the web app deployment, we use Heroku separately. So we use Dilto, Pico, Fire, and so we did both of them.
I get that, but what I'm trying to say is like, how did you get? Because if you pickled something, right?
Yes, yes.
So the stuff you pickled, how did you create it? What did you pickle?
Yes, let me just move to this slide that showed the whole workflow. So first of all, these pre-processing steps, what we did was to create each of these steps as a custom transformer, and then we encapsulated the two of them in a circuit-length pipeline. So where we, after fitting, then we then pickle the fitted transformer, same for the CNN and LSTM model, and same for those. So during the prediction in the deployed model, what just happens that it's going to load our pickled file and then use it to run the transformation and prediction.
Yeah, how did you create? The code that created the pickle, is it in the pipeline or is it somewhere else?
Yeah. Yes, is in our GitHub repo. Let me just link to that right away. Just show you.
Okay, I'll check it out on the slide.
Okay, check it out on the slide.
So where's the code that actually created the model?
Okay, yeah. So let me just go to the deployment since for the Pico. Yeah, this deployment, and this is the web app, and let's see. So this is the Flask. The Flask Python. Yeah.
The model.
No, this is not one. This is the one that loading the trained model.
The SASE model, the inferencing.
This is one that linked in the model. Okay, you're asking about the model. So the model is here. These are the models. Where is it? Yeah.
Yeah. I'm also interested in the model, so I don't have to ask.
Okay. Yeah. That's the final model of blended CNN and LSTM. So it's loading. Come on.
Yeah, it's GitHub. It's not.
It fails sometimes.
Okay. Yeah. Yeah. So this is the modeling. So first thing, let me just go straight to the model. Yeah. So this picture that I showed is here because it explains everything. So the first transformer, this is it. Get tokens. I created a custom transformer a circular transformer that can fit and transform data, and same for the next preprocessing step, that is text to sequence, and same for the padding. Then for our model, this is what built our CNN model, and then this function built the LSTM model. Then I created a custom transformer again, but it kind of disguises like a transformer, but what happens underneath the hood is prediction. Yeah, so when the preprocessed data comes into the CNN model, for example, when it does fit and transform, what goes on is that it's actually predicting. And then, and same for the LSTM model, then we use a blender, a multilayer perceptron, but this time a custom classifier to blend the two output. And then these are the training variables, the learning curve, and the F1 scores.
Mm-hmm.
Yeah.
Okay. So, where did you pickle? Did you pickle the model at any point here?
Yeah, yes, I did that. Yeah, let me just show you right away. Yeah. Let's see.
Yeah, I'll check it out. I just want to make sure it's in the right place. All right, cool. Good stuff. Thank you.
Okay, all right.
Yeah,
Thank you very much.
Okay, I'll just quickly follow up. So apparently, when you said transformer, I thought you were using the transformer model, but you just, the transformer you're talking about is what transforms the text. So
yeah.
my question is that what exactly are you using for feature representation of the text? So you have the data processing, right? But there's something that should be between after your padding layer before you actually get to your CNN and your LSTM.
Yes, that's the word2vec embedded layer. So what we did was that we use word2vec. We tried TF-IDF, but word2vec apart from TF-IDF.
Are you using a pre-trained word2vec, or do you train your own?
No, we trained it on our data set, and then we got the embedding matrix, and then we pass the matrix at an upper parameter to the CNN and LSTM model during the building of the models. I think I can just show you that here.
No, that's fine. We can go to the I don't know if Gilda has a question. But yeah, that's what I wanted to know. Thank you.
Okay, all right.
Yeah, good stuff, man.
Thank you.
Yes, thank you, Jolomi. Thank you to our judges as well. So we'll move on to the next one quickly. Heart failure group. And that group is represented by Chigozie Umbonu and Gurav J.
Can you hear me?
Yes,
can you hear me?
Chigozie. Yes, Chigozie.
Let me try and
you
share
have 2 minutes.
Is my screen showing?
Not yet.
I already did. Let me do it again. Hold on. Share screen.
Yes, Chigozie, please proceed. We can see your screen.
Okay. I'm sorry for the delay. Okay. Okay, good afternoon. My name is Chigozie Umbonu, representing Group 7 Heart Failure. These are our team members. Some people have this misconception that heart failure is a phenomenon that happens suddenly, but this is often not the case, as different factors like diabetes and anemia and other factors contribute to a person suffering a heart attack. Our task as a group is to build a model that could predict if a person would have an heart attack or not using these features, so people can take preventive measures. The previous group that worked on this trained a random forest classifier using 7 features out of the 12 available features and obtained an F1 score of 0.9 and accuracy of 0.96. Our approach was to first collect the data, perform EDA, preprocess the data, select a model, train the model, build a pipeline, and deploy the model on a website. These are some of the EDAs we performed. So generally from our EDA, we noticed that there was an imbalance in the target class of the data set. So we handled it by smoothing. We also tried to engineer some features and tried PCA, but they didn't yield good results. Finally, we
have 30 seconds more.
We performed a 10 test splits and tried several classification models, logistic regression, decision tree, random forest. Random forest gave the best performance on the test data, getting a recall score of 0.97 and an F1 score of 0.95. Then we built a pipeline on Google Cloud Platform using Keyflow. This is the pipeline. Then finally, we deployed the model on a website where you can go and make predictions. So our recommendation is more data sets should be collected and the model retrained because the observations were quite small. Thank you.
Thank you, Chigozie. That was quite on time. So we'll move on to our judges now.
Can you explain how you said the data set was very small, so you decided to use Smart? I think I saw it in the last slide. Can you explain what you did with Smart? Yeah.
Okay. From the target class of, that is the class we are trying to predict, which is the death events. Observations of 0 and 1. 0 for when a patient would die and 1 for when a patient would die. So there was an imbalance in the target class. First of all, we had about 299 300 observations of data sets. So the instances of a person would die, which is 1, were just about 53 or so. Then the instances of a person would not die was 206. So there was quite imbalance in the target class. So we used Smooth to upsample the data to create more observations to train on.
Okay. So basically there wasn't enough data sets, so you just augmented the data source with Smart.
That was one of the reasons. Trying to train the model on the amount of data sets we had was performing quite poorly, and again we couldn't we couldn't use accuracy as a metric for evaluation because of the imbalance. Obviously, to always predict the majority class, and so even if we have a high accuracy, we couldn't rely on that. And so the only option we had was to either downsample the majority class, but that wouldn't be a good idea here because the data set is quite small and we needed more data to train the model. So we used Smooth to upsample instead.
Okay. All right. Yeah, and yeah, we can do a lot if there's not enough data, but I think this is a good effort. So let's just step back a little bit on the pipeline. So can you just explain the process you went through? I see you did the analyze, but the analyze is floating and it's just one step. What were you doing in the analyze component on the far right, on the far left?
Okay, so after you create the volume, the analyze is like checking for all the dependencies you've downloaded for the pipeline. It's checking all the functions you've created and if all the libraries needed to perform everything here has been met. So that's where the analyzing part, what is happening there.
Okay.
Did you get that?
Yeah,
okay.
I got it.
After the volume down, the next, what we did from the data, the preprocessing, everything we did under preprocessing, from the minimum maximum scaling, from the smoothing and all that, they fall under the preprocessing. Then the skill transform, then the training, model validation, and evaluation.
Okay, cool. Yeah, just do me a favor. Yeah, draw us a favor. Just drop a link to the Git so that we can review the code.
Okay. You can also check the model on the website using the also, and you could also check the website and make predictions and that.
Sure, we'll do that. But yeah, even if I make prediction, there's no way to validate. Yeah. All right.
You could actually validate it.
Really?
You could. Okay. The model is quite intuitive. We performed we did extra research on the observations of the data sets. So these values here, they are medical values. Like there are some certain levels of these compounds that should be in the human body from our own research, like the creatine phosphokinase or the CPK. So we kind of featured a new column on the data sets, although we didn't use it to train the data set. So we featured some new columns which would tell a patient if the level of this substance are quite high or low or moderate. So when you're making predictions using our app, in as much as you pass in your original data, it kind of tells you if these things you have in your body, are they low or high, and what you need to do to step them down.
So the indicator values, right?
Yeah.
Yeah. All right, cool. I think I'll follow up with you on that, just to make sure this is right. Well, it's very interesting. Yeah.
Yeah, which model did you guys deploy finally? Random forest?
The random forest model.
Okay. So let's say doctor comes to you guys now and say, okay, then you give for a prediction for a patient, if the patient is going to live or not. And then you say, yeah, this is the patient is going to live or die based on this. But the doctor actually wants to know the reason behind your prediction. Like you should, so I'm actually going into explainability. Did you do anything that would sort of explain every single input to the model and how they perform?
Okay. Here's the thing. These data were collected from patients from past and present, people that had all these underlying health defects. Let me make reference to the data set so you could understand what I'm saying. Get a clear picture.
So actually, I would like to add something in that the data set we have. So in the prediction, we show like this value is particularly high for you or low for you. For example, if you the patient come and say that so this is my test reports and these are sodium values and phosphokinase value, and we enter in the model, then the model gives a user profile also that this particular value is high, which may lead to the death event of the patient. So basically, we can check the severity of various blood levels.
Okay, so were you using some post hoc interpretability tool to do that?
So basically, we refer to the standard medical values which are prescribed on.
Okay.
And we categorize according to that high, normal, low, and then we are.
Okay.
So just to follow up on that, if I pick a patient report with like all those indicator values that were tested, and I give it to you, can you go back and tell me like if this patient is at a high risk of heart failure or not?
So basically, we'll show all the 12 features which we use, and we will give them that these features are high, these features are low for your for this particular patient. So then doctor can use his studies, which he is specialized in, to give the particular medications and check the severity of the disease.
Okay. All right, good stuff. Yeah, we'll follow up with you guys on this. It's very interesting.
Sure, sir. Thank you.
Yes. Thank you, Gurav, and thank you, Chigozie, for that work. So proceed to the next team, university admission. Emmanuel Ogunwede and Suta Salu are representing that group.
Okay, can the previous group stop sharing so I can share my screen?
Oh, sorry. That's on the.
All right, great. Please let me know if you can see my screen. Can you see my screen?
Yes, we can see your screen now. Yes, we can, Emmanuel.
Good afternoon. Starting on all existing protocols, my name is Emmanuel Ogunwede, and I'll be presenting on behalf of the University Admissions Group. Okay, so it's popularly said that to be forewarned is to be forearmed, and that by failing to prepare, one is actually preparing to fail. Now, getting into international graduate schools is actually very competitive, and hence there's the need for students to be able to better understand their chances, building solutions that can help students better understand their chance of getting into these schools. Now, while the previous group who worked on this focused on building a model and optimizing their IMSE score, we actually wanted to build a product out of our model. And as with every other successful product, we had to come up with certain criteria our product will meet for us to call it a successful product. And these criteria are actually just the accuracy in terms of getting the lowest RMSE score possible, interpretability. So we're building a model that will directly be used by an end user. And we didn't want it to be a black box. And in order to help the end user understand what was going on in the background, we decided to build an interactive dashboard with insights on the nature of the data that was used. Now we realize that in our machine learning pipeline, what we actually had to focus on was feature selection for our case, because we're also considering, and so the features did not just have to make sense with two criteria. Every feature we selected had to meet, and those criteria are actually the availability of a feature to the end user at the time he's trying to make an application to graduate school, and then the importance of the feature to the model. Now, with respect to the importance of the feature, we were basically analyzing based on correlation to the target feature. And then we also analyzed based on importance of the feature, the model's performance. And so we're able to select which is CGPA, the GRE score, TOEFL score, then research. These four features met our criteria, and then we built a model. So because we wanted to get the highest accuracy, we had to actually go through the process of tuning with our selected features. And then at the end of the day, we're actually able to achieve reasonable accuracy after eliminating four features. And I think the biggest challenge for this project was that thinking of our model in terms of a product really stretched us, because we're not only trying to build an actual product. And for future recommendation, if anybody is able to gather the SCP data set and their scores, it will actually help a student know beforehand the quality of his SOP, and that would actually help us in building a better model in the future. We built a web app also. Thank you.
Thank you. Thank you, Emmanuel. Thank you. Our judges now.
Quick one. So what's the what does the university rating and research stand for?
Okay, so it's basically how the university is being ranked globally, and it has a value from 1 to 5. 1 meaning the university is like that's the highest possible rating, and then 5 is like the lowest possible rating. And then for the research, it's basically if the student carried out a research or not, before applying to graduate, if he has done a research before or not. That's basically it.
Okay, sure, thanks.
So based on what you're saying, you're based on this chart that I'm looking at, it seems like your recommendation, or probably assumption, is that statement of purpose doesn't matter as much as your CGPA.
Yeah, it was very interesting to see from even the correlation. Statement of purpose was actually higher than research, and so like it was very correlated to the chance of admit. But then in the model, we built quite a number of models. It was always poorest feature, and that just basically taught us that, or reminded us that correlation is not always equal to causation.
Well, Kolebik, because of the samples of data sets in each, and it's not really normalized, because most people who go to grad school will always have a CGPA, but not all grad school require you to write a statement of purpose. So if the sample size on that is very low compared to CGPA, which is up, for you to go to grad school, you need CGPA, but for you to go to grad school, not all grad school wants you to write SOP.
Yeah, well, basically, we did not consider SOP in our final. It wasn't part of the final features we selected, first of all. And then also, yes, not all schools would actually require that from you. And then, like what I said, the criteria for selecting a feature, we had to make sure it was available at the time the user was trying to apply. So we don't know the SOP score because it's the university that will determine it. But then we are actually sure that the students must have a CGPA, and then GRE and TOEFL score if they are required. And then he knows if he has done a research or not. So those features met that criteria, and then they were actually important to the model too. So that's why we used only those 4.
Mm-hmm. Yeah, I think it's logical based on your explanation, because for you to get admission, you need a CGPA, then maybe your GRE and your TOEFL score and all the other things. I think it makes sense.
Yeah, it'd be nice to do some form of dependency type model, like which one depends on another. and in what order? Because I don't think this is the right order. I think there are cases where you get an admission solely because of the person who's recommending you.
Exactly.
And there are cases where you get an admission because of your GRE and your CGPA. The type of university that you're coming from also matters mostly to get an admission in some universities. So, well, it's a good topic.
Yeah, just to add to that, I think we're very limited. We had just 500 entries, and we didn't have any missing values. So we had as many SOPs as we didn't have to drop anything. And I've thought about it too, because I've applied to certain schools, and like this was quite personal to me. So yes, I totally agree that different schools have different criteria, and that's why we decided to build a dashboard to explain to a user why this model was actually behaving the way it was. Just to explain the data set in like summarize our EDA in form of a dashboard and expose it on our web app.
All right, well, good presentation. Thanks.
Thank you.
Thank you, Emmanuel. Thank you, guys. So we've officially reached the half mark. Now we'll now step into the second half of the presentation. So we'll start with group number 9, campaign finance. And the presenters are Christopher Adigwe and Oladipupo Ibeun. Chris, you can proceed now.
Yeah, good evening. Can you hear me?
Yes, we can hear you.
Okay,
But you're not sharing your screen yet.
I'm sharing my screen now. So can you see my screen?
Yes, you can see your screen. You have 2 minutes.
Okay. My name is Christopher Idigwe. I'm the project lead and presenter for Group 9. We're working on campaign finance. These are my team: me, Christopher, Patrick, Joseph, Countess, and Ali. Moving forward, our problem statement realized that people campaign fundings are widely believed to be considered as an indicator for candidates to be successful in an election. So, however, we've noticed several campaigns of late where candidates, with even the funding they have been unsuccessful with their election, and we decided to analyze this data to determine if truly campaign finance really influence election results, or if there are any other criteria for candidates to be able to win election. So moving forward, this is our project approach. We got our data and we decided to split the data into 3 categories for the presidential candidates, senatorial candidates, and House of Representatives candidates. Why we decided to do that? Because based on criteria for election, the criteria for winning presidential and House of Rep elections are different from that for the senatorial election. Then after we did that, we did some EDAs on each categories. We noticed
Chris,
that
you have 30 more seconds, please.
okay, we did some EDAs, and we know that campaign finance does not really affect election results for both presidential and House of Rep. Then based on our model, we use the XG boost, and we were able to get 100% for the presidential election based on the number of data entries for the presidential election were not that much, while for the Senate candidates we're able to get a 91% for all categories, and for our F1 scores was also 0.91. Similarly for
please round up in 10 seconds, Chris.
So part of our challenges we encountered during the project was the data was kind of imbalanced. We're having more candidates that had won the election compared to candidates that have lost. And also, we had some data points that were unable to pre-process, which gave us a hard time. So we had to drop
Thank you.
Data points. Thank you.
Yes, thank you, Chris. Thank you, Chris. Sorry for cutting you, but on time. So to our judges now.
So I have two questions. One, like, what exactly are you using machine learning to predict, and what are your features?
Okay, we're using machine learning algorithm to predict who will win the election. Our features were based on campaign fundings, disbursements, party affiliation, and we had over, like, I think more than 20 features. I can't remember, but those are the key features that we took as part of our model to be able to determine who will win election. But what we did, we divided into three categories: for the presidential, for the senatorial, and for the House of Rep. So I think for the senatorial, we had to drop the voting part, because basically every data point they were empty, and based on the constitution and how they elect senatorial, I think the voting part was not needed, so we had to drop that part. But for the other parts, basically I had to use all the features for the presidential and House of Rep. Thank you. Sorry, can you hear me?
Okay. Yes, thank you, Chris. I don't know if Bjorn or Charles has anything to add.
I'll pass on this.
Yeah, I'll pass as well.
Okay, thank you, Chris. So we'll move on to the next one, police shooting group, and this group will be represented by Triumph Oge and Oluwasayo Akinkumi.
Can you see my screen?
Yes, Triumph can see your screen. Please proceed.
All right, good afternoon, everybody. I'm Triumph, and I'm representing for Group 10 police shootings. Meet the team members, and our problem statement was to ascertain if the shootings of police, US police, on victims were justified or unjustified. I will also try to see if we can predict what will happen in future years, how many more people will be killed by police. This is a view of our data set, and data was gotten from Cabo. After doing some analysis, we saw that over the years, about 1,000 people were being killed by the police, but for 2020, there was a decline because only 6 months data set was prepared for 2020. Then we looked at the states in which these killings occurred the most and the states in which these killings occurred the least. Then we tried to find out if there was a relationship between race and the amount of people being killed. We saw that from the data set, more whites were being killed. But looking at these killings as a proportion of the race in the United States, we saw that more blacks were being killed, followed by natives and Hispanians. Then we found out that most of the people that are being killed were males within the age of 20 to 40 years old, and they had no signs of mental illness or not. Even the police officers who shot them didn't have their body cameras on, and these victims were not fleeing from any crime scene at all. So some of the existing models that were there were logistic regression, chain generating by random forest. We further worked on a neural network, and in our pipeline, we used a logistic regression model because it performed really well, and we also used the neural network model. So here is a short video of our model in deployment. It tries to find out the probability of the shooting being justified.
Triumph, you have 30 more seconds.
For our prediction, we saw that by 2021, about 800 people more will be killed throughout the year in the United States. In summary, we saw that more blacks were being killed and more of these killings occurred during the first half of the year. Thank you very much.
Right. So,
go.
Okay. Thanks, Charles. It's a good topic, and what I would like to add on this one is what kind of assumptions did you make? And this is more of a very sensitive topic, and it has to be a topic that people have tried to address in the past. So what kind of assumptions did you make to get to the results that you got to, and what were the previous models used, and what were their own assumptions as well? What were their own, how different was their own results from yours? So it's kind of two questions.
Okay, Oluwasayo, please, are you on this call? Emmanuel,
Yes, I'm here.
can you? All right, please, Oluwaseyi, you can answer the question.
Okay, sir. So basically, this is a continuation of what has been done by the previous group. So the assumption they made was that if the person that was killed was fleeing and didn't post any threat level, or maybe post the threat level, then we can generate some labels from just those two features. So that was actually what we built upon, and our focus for this phase was basically just to see if we can build an end-to-end machine learning system from what has already been done. So that was their own assumptions to generate the labels from threat level and whether the victim was fleeing or not. But what we found out was that when they built their own model, they used those features, those features that made them to generate new labels. They also used it in building the model, which actually gave them a very high score. I think they had 0.91 or something. So what we decided to do was to remove those features in building the model, because that would obviously give us a high performance. So at the end of the day, we got a score of 0.6, which was lower, but I think we could actually improve that with hyperparameter tuning. But because of time, we're not able to carry out the hyperparameter tuning for the whole system.
Okay, so when you say that the police shooting is going to increase, I think you said I think Triumph may have said a number in the next couple of years. How are you able to validate that?
Yeah, so that part of the project is actually quite new, because we try to make use of different things, like generate different ideas on what we can do on the project. So we were not able to actually validate that. We only try to use the ARIMA model to see what the prediction looks like, but we're not able to validate that because of time as well. So.
All right, well, that's all I have.
Can you go back to the summary slide? So California, Texas, Florida have recorded the most number of shootout deaths. Is it like between the police and the community, or is it crime-related shooting?
From data provided, the type of shooting wasn't specified, but due to our research, we found out that California had in California, there have been some mass shootings by police and citizens. So we thought maybe that's why it would be the highest state, since there's been mass shootings in California and Texas and Florida.
Okay. I mean, I think like Bjorn said, it's a very sensitive topic, and I mean, you guys are a little bit disconnected from it because you're analyzing data that doesn't really impact you right away every day. So, but the way you said it is a little bit scary. Like you're predicting like how many people will be shot or killed, which I mean, I won't put it that way. I mean, rather, what you want to do with this data set is to investigate what people need to do to make their lives better, so that they won't be in a situation where, God forbid, something bad happens and there's gunshot due to crime or violence and things like that. So I love all the things that points to all those things is around. There's the economic aspect of it, and a lot of other variables attached to this and things like that. So, but I think watching out for all those indicators, kind of like the guys that did the predicted the ads failure and the indicators and stuff like that. Is it possible to come up with like a set of values set of indicators that if you're doing this, if you're at this place, if you're at this place, you're not likely going to be in a situation where there's a gunshot and things like that. So I think that's a lot more better than predicting like this is what's going to happen based on what you've seen in the past, because it's a random event. It's not like people are like shooting every day in these places. It's like, man, how can you identify things that a young 18-year-old or 21-year-old needs to do to stay safe and not be in a gang violence that will result in gunshots and stuff like that? Don't do drugs. Stay away and get busy. Don't move around with bad gangs and stuff like that. That will reduce the likelihood of all this event happening. So those are variables that you're not saying, but you're just interpreting the data and you're predicting. So I rather want to see this in terms of those indicators that will help people make good choices and good behavioral changes that will not get them in trouble. Does that make sense?
Yeah, it does.
Yeah, you wanted and good points and good call outs. And I was hoping that by the end of the whole presentation, we'll give a summary. Well, yes, you want to scope your any project that you're working on. Projects should be scoped to something, and it should be like if it's police shooting. All right, this is the problem, and see it more as a funnel. And then at the very bottom of the funnel is a specific recommendation that you're making, and it should be something actionable and somewhat logical if possible.
Okay.
I absolutely agree with Charles and Bjorn. It's pretty sensitive. One thing I also wanted to call out, and I think Bjorn actually mentioned it on the last presentation that we did a few weeks ago, is also the way you present data really matters. So for example, you said California, Texas, and Florida have recorded the most number of shootout deaths. Typically, what you do in this case is what's the number of shootout deaths per 1,000 people, for example, or per 1 million people. So you need to be able to rescale the data when you're trying to present it, and that gives a much better representation of the data than just number, because these three states are probably among the states with more people. They are the most popular states.
Largest three states. Yep.
Yeah.
Okay.
All right, thank you, Triumph. And thank you to our judges as well. So we'll move on to the next group. And then maybe I should just add that the next 6 groups I'll be presenting are actually fresh projects. The last 10 that I was presented, they improved on the work of the stage E groups, but now these ones are quite fresh. So Group 11, food delivery, and that'll be represented by Precious Adedibu and Praise Taiwo. Precious? Okay, Praise, share the screen. Yeah, Praise, we can see your screen. Praise, we cannot hear you if you're speaking already. Praise, you're mute, so we cannot hear you.
Sorry. I hope you can all hear me now. So
Yes,
good day,
we
everyone.
can.
Good day, everyone. Our open source project is titled Food Delivery, and I'll be presenting alongside my project lead, Precious Adedibu, and I am Praise Taiwo. These are our team members. In our world today is being massively transformed by technology, and food industry is no exception to this transformation. And therefore, predicting the time taken for food delivery has become very valuable, not just to clients, but delivery companies and restaurants. In solving this problem, we defined 4 objectives. Firstly, to perform exploratory data analysis Then secondly, to perform engineering and build between a model, then created a pipeline for this. So our approach was to source a good data sets, clean the data sets, and perform feature engineering and the rest. In cleaning data sets, we removed unwanted symbols from the data. We also dealt with non-numeric characters from numerical columns. This is an illustration for our project workflow. This data set was a collection of 13,862 records of deliveries from 8,661 restaurants in India. It had 9 features, and the delivery time was a target variable. These are the results for our exploratory data analysis. First of all, we're able to determine the cities with the highest food delivery count, with Noida city coming first, followed by Pune city. We're also able to determine the food delivery time frequency. Hereby, we're able to determine which the most food delivery occurred within 30 minutes, followed by 45 minutes. We also determined the cuisines category.
Praise, you have 30 more seconds, please.
Okay. Mostly by clients, and fast food was the most ordered cuisine category. And here we determined the average cost of most food deliveries, and here we determined the top 5 cities with delivery ratings above 4.0. My colleague will go on from here.
Okay. In order to improve the accuracy of our model, the following new features were added: the minimum order 0, the minimum order to cost, the reduced by votes, the number of restaurants for each city, the number of branches for each restaurant. In developing our model, we employed the use of 2 machine learning methods, the random forest and light GBM.
Precious, please round up in 10 seconds.
We carried out one-hot encoding on some features, particularly the cuisines, and label encoding on some features. After fitting and training our model, we made predictions on our test data and found the light GPM model gave the highest accuracy of 0.821 and the random forest with an accuracy of 0.819.
Thank you, Precious. Thank you, Precious. Thank you. Sorry. So we'll move on to our judges now.
Yeah. Okay. Okay, can you just finish up on that Keyflow slide? I'll borrow you like 20 seconds of my time.
Thanks, sir. Our data engineers successfully built and tested a pipeline using Keyflow. Following. Next slide.
Okay.
In building the model, the data cleaning and feature engineering were the most crucial aspects, and we experimented on several features to get the best accuracy. The challenges we faced were that we couldn't determine the dates the data was obtained, and we had to carry extensive research on Indian cities to make sure the appropriate city location, cuisine categories, and other details were input. Thank you, sir.
Yeah, so you mentioned something about, I think there's a little bit of echo. You mentioned something about determining the peak period when people are going to order, which is like the surge period. Can you tell me what you guys did around that time? Because it's a very interesting problem. They do it a lot at Uber, and a lot of things when you need to drive traffic and manage the scale of your application on the back end. How did you guys model, build that? Got the features that you need and model this period and this spike period. And the other question I would have in addition to that is like, was the spike or surge period always constant, or it varies based on seasonality? Or was there a pattern to it that you could track?
It didn't have the dates, the time the data was recorded, so we couldn't work based on seasonality and we couldn't get details on the preparation of the data, the time. Then
okay.
Okay, first question. I can't remember. The first question.
I was just trying to find out how you guys were able to determine the surge and peak period from your. How did you guys implement that, the feature engineering and the modeling? Well, if you have it in the code, I can go ahead and check out the code. So I don't want to take too much time from.
Okay. Can I share? Let me share my own screen.
Okay.
Okay.
Yeah, Precious, you need to be faster.
Sorry. Okay. The main part in building a model was the data cleaning. The features that we had were like average cost and minimum order. We had to remove the currency symbols from the features. Then, and the main challenge is also making a new column, a new entire column for the location, which is city. So every one of these locations, we had to do research to find out the exact city. For example, this Noida here, for example, can be in Mumbai. And there will also be another entry called Mumbai there. So we had to, the code here, down here is for that. We had to create a mapping of all the different cities. So in total, there were 8 unique cities at the end of the day. Then, next one. Then we created other new features. Most of them were created by dividing other features by some other features. We experimented on several of them to improve their accuracy. Then, so at the end of the day, we had the following numerical columns, which was rating the average cost, the minimum order, the restaurant branch count, the number of restaurants.
Precious, I'm afraid I'll have to time you out.
Sorry, I'll be done soon.
Yes, 10 seconds, please.
So at the end of the day, we carried out one hot take coding. So because of that, we ended up with a lot of columns, totaling 11,272 columns. Then we converted them into a sparse matrix using SciPy. And we split them into a training and testing sets. Then we used training and GPM.
Thank you, Precious. Thank you. Okay, so I don't know if someone wants to hear anything from the judges before we go to the next group.
I'm good. I just want to see the source code at some point.
Okay, thank you, Charles. Nothing from Wale or Biodu?
No, nothing from me.
Nothing from me as well.
Okay, thank you. Thank you, Precious. We'll move on to the next one very quickly, Startup Success. And that group is represented by Edeki Michael and Oluwafemi Uju. Yes, Uju, we can see your screen now. Make sure you unmute yourself because we can't hear you.
Hello, can you hear me now?
Yes, we can.
All right,
Let's proceed.
so,
2 minutes.
Program statement. And as we all know, every single year we have tons of startups being interested into the business world. And then these startups have to, compete with other startups in their respective niches. And they also have to, make important decision making, do you understand, for them to, get successful and for them to attract investors. Yeah, and for existing solutions, we found that like not much work has really gone into it. Like if you check the dataset category on Kaggle, you see that there's really been nothing much that has been done there. And then our approach was to carry out a sort of detailed exploratory data analysis, do data cleaning standard and clustering model. Yeah, so this is the description from Kaggle. Yeah, for processing, we had to, because there were like a couple of data sets, so we had to merge some of them and then sort out the data assessment issues before we started working on them. Yeah, and for EDA, we did plenty visualizations coupling with their current status, operating, acquired, IPO, closed, and then other visualizations, like that showed the kind of institutions that were inside, that were involved in startups. I'm saying the ISTF being Stanford University, and then you just see a couple of visualizations, like showing the different affiliations, professional backgrounds.
Ojo, you have 30 seconds more.
All right. So for the main work of our model was clustering. So yeah, we clustered the data points to be able to segment the kind of margins that you have, so that we'll be able to focus more on the ones that were successful, so that we could merge their success standards. And yeah, we used PCA in our clustering model so that we could reduce the dimensionality. And this even basically shows the relationship between the new components and the old components after PCA. So basically, these scatter plots.
Please round up in 10 seconds.
All right, show show the arrangement of the clusters, and then these are the post-clustering analysis that we found after doing analysis on the clusters after clustering. Yeah, I found out that clusters in the cluster 6, the startups there were able to raise more. They were able to raise more funds, than the other startups in other clusters. And then you see that startups in cluster 5 and 6, when we compare their unique ID,
Thank you, Femi.
All right.
Thank you, Femi. So sorry I had to cut you.
Yeah, no problem.
Okay, now to our judges.
I think I'll pass on this.
Okay. I think I was muted before. So your cluster, how did you find the optimal number of clusters?
Yeah, we used elbow method. Let me put that out. Yeah. Okay. No, sorry. This is it. So what it basically does is that it plots a graph between the number of within cluster sum of squares and number of clusters. So you would notice in the graph, I don't know if I could try to highlight that. There's a point in the graph where the within cluster sum of squares don't really change anymore. So that was what we used as an optimum number of clusters. And then even after, because we did clustering without PCA and after PCA, and even after PCA, the optimal number of clusters did not change. Yeah, so that was how we found out the optimal number of clusters.
Yeah, can you quickly go to slide 17?
What did you say?
Slide 17.
17, yeah.
Okay, so this is typically what the data point looks like when you map it, right?
Yeah.
Okay, so yeah, so the idea about of K-means is that your clusters they actually need to be in centroid form, right? But the way your mapping looks like it's actually entirely different. You could see it looks like a ring or something, and it's very possible that K-means is not the best model.
Well, actually, this was done without clustering. This mapping was done after EDA. This is what it actually looks like after clustering. Something like this. Yeah.
Okay.
Yeah.
Okay. And what's the take home? Startups in San Francisco get more money or what?
Oh well, technically, and I think my major point of recommendation is that startups in Africa really, when you compare the kind of data, when you compare the kind of access to investment that they have, compared to startups that have how I call it, connections to advanced Ivy League schools and affiliations with giant tech companies like Google, you see that they usually are more successful than when you compare startups in Africa. And the most successful startup when we did our clustering only had 2 startups from Nigeria, as I pointed out, Jumia and Hotels.ng. And that was majorly because of the amount of funding that that went into them. Yeah. So and then when you compare, especially
sorry,
yeah.
Sorry to cut you off. What year is this data?
Yeah, the data stops at 2013 actually from
Okay.
Yeah,
So because so much has changed since 2013.
yeah. So much. That's why I put that in recommendation that
okay.
Yeah.
Oh, okay. That makes a lot of sense. Yeah. All right, good stuff, man.
Yeah.
Thanks.
Thank you.
Yeah.
Okay, thank you, Wally.
Yep.
Anything from Biojo?
Oh no, nothing from me. Good job.
Thank you.
Okay. Thank you, Oluwafemi Ojo. So we'll move on to the next one, house pricing. House pricing group is represented by Ilo, Miracle, and Kudus Okwayemi.
Bye.
Yes, Ilo, we can see your screen.
Yeah, good afternoon, everyone.
Good afternoon. You have 2 minutes.
Okay. So my name is Miracle, and I'm presenting my group. So this is the beginning of my presentation. So we're talking about house price prediction, and these are my group members. All right, so the problem statement, we understand that people are just trying to buy houses based on try and error basis, so they don't get real value for their money. And that's the essence of this model. We want to see whether we can give them a model that can predict the actual price of a house if they give us their choice features, as in what they're looking for in a house. All right, so the existing solution, like I said earlier, is that people are doing a trial and error basis, and then anything that comes up, they can take it as a value for their money. So what's the approach? We did data wrangling. We looked at relationship between models to do a good storytelling. Then we did a model to predict the price of the house, then a web app, and then an easy orchestration, which is the pipeline for our model. So we have the data set from Cargo. These are the description of the data set. We have categorical variables and then the numerical variables. Here we'll have the features that speaks more of what determines the price of a house. We'll have the year it was built, and then these are the outcome of our data wrangling, and then the storytelling. We'll have the year it was built. It did not have much effect on the price of the house. Eventually, we saw that much houses were built in the recent years.
Miracle, you have 30 more minutes.
Okay, fine. So we'll have the C2. The C2 showed the house with the highest number of the city where the highest houses were actually purchased, and then we also found that there are also numerical variables effect, like number of houses, number of bedrooms. Then let me move straight to the model. So we'll have the model, we'll try that different models, and then we came up with CatBoost being the highest one, giving us the RE2 square with the 0.64, and then the lowest RMS core value. Then
you round up into
the web app, and then the pipeline, and then these are the. Thank you.
Thank you. Thank you, Miracle. Sorry for that bridge. So we'll move over to our judges.
I can go with this. So just quick correction. You mentioned, I think you was trying to say Seattle. You called it C2. So just fix that next time. It's Seattle. That's where Amazon and Microsoft are. So just
all right, thank you.
Yeah, pointing it out. So the other thing you said is like most people buy properties. They just try and error. I think that's also true. That's not true. It's like most people, their properties are their biggest investment or the biggest thing they buy. So it's not just try and error. People know what they want to buy. And most of the time, whenever they want to buy property, especially in the US and in most places, you look at, if you have a family, you look at the school district. Is the school in that neighborhood good? What's the crime rate? What's the proximity to your workplace? And a lot of other variables. So those are the things people look at. So they don't just do it by try and error. People actually have some basics that they look at. And it's an investment property. You now want to know, like, okay, if I buy this property for $100, how well is it going to appreciate in the next 10 years? Are people going to move to this area? Is there going to be a demand for it? And things like that. So all those things need to be factored in place. So can you just go ahead and explain what you've done in terms of all those variables, or what indicator values you used in making your predictions and building your models? What input values?
All right, thank you very much, sir. Okay, what I actually meant by trial and error basis was that they don't have an insight of the price of the house that they're going for. Of course, there are features like, okay, in what city is it located? What's the number of bedrooms? What's the number of bedrooms and all of that? But beforehand, they don't have the insight. Okay, let's say based on this number of houses, based on this number of bedrooms, and then whether it has a waterfront or maybe the number of views and all of that. Okay, this is the price I can give for this. So that's what I meant by that. Okay, fine. The features that were as they were given to
even with that, people know how much a rough estimate of what they're going to pay for a house. It might be off by like maybe a few $1,000s, but if you want to buy a house for, let's say, $50,000, you know, like, okay, you're going to pay probably 52,000 or 48,000 in that range, but you can't sell a $50,000 house for $50 million. So people know how much a property should be worth by the time they're trying to buy, based on a lot of all those variables. So I'll still differ with you on that, but just go ahead with the model and how you determine that.
Okay, fine. Thank you very much. So the model, like, okay, these different models that we tried, we did a hyperparameter tuning, and then we also came up with the best, that's cat boost, and that gave us a 0.64 R2 score. And then this may seem low because the data set, after doing data processing, removing all the outliers, and then some of the, because we found in the data set that we had about 49 entries that had no price for the house that was sold. And we saw that as an abnormality. So we removed that, we dropped that from the data set. And then we also saw houses that did not have the number of bedrooms recorded for them. And then the number of, that's zero number of bedrooms, and then zero number of bedrooms, which can't be possible in a house to our own understanding. So we also dropped that. And then after doing all the data processing, the data actually reduced. Before it was 4,006, and eventually it's reduced the more. So we saw that affected the score. And then, so if we have more data sets for this, for this project, definitely the score higher. So we understand that from this chart here, that CatBoost being categorical boost model, because of it's robust to outliers, and then also for categorical features, it was able to come up with a higher score, as we can see here. Then this is our model. Sorry, as our pipeline for easy end-to-end orchestration. We did the pre-process, the trend and predict components, and then we have the highest prediction, which we can see here. Thank you.
Okay. So can I see the inputs that went into the model, and how did you determine the fields that you need? And did you do any PCA, principal component analysis, and things like that? How did you determine the features that went inside your model?
We don't have time to share that. We have the trend sets and then the test sets. And then we'll have the, can you hear me?
Yeah, I can.
Okay, fine. So we'll have, yeah, so we have the price as a target variable, and then the features as our that's the independent variable. Yes, the independent variable to predict the dependent variable, which is the price. So those features are like,
how many features went inside your model?
Hello? Can you hear me? Hello, can you hear me?
Yeah, I can hear you, but it was breaking. Okay. All right. Sorry, I think I see it now.
I have a follow-up question. Can you go back to where you have your
Okay, fine. So like I was, we have the square lots, we have the H and the output.
Hey, can you hear me?
Sorry, I didn't get that. Yes, I can.
Okay, can you go to where you have your model results, the RMSC, and
okay, here is it.
No, yeah, just to be clear, you're actually predicting house prices, right?
Yes.
Okay, so house prices are in the what hundreds of thousands of dollars, right? So I don't understand how your RMSE train and RMSE test are in decimals.
Yeah, because we did data processing and then we did a normalization of the data, and that's made that data to appear between 0 and 1. So that's why we are having these as the RMS scores between 0 point something.
So you normalize the target
and all of that.
Okay.
We use the mean mass scalar for the
target variable also.
Yes, exactly, for the whole data set.
Okay. All right.
So we also had a web app. So we found the need to have as a user interface for people to go and try out our model. And that's what we have here. And this is the kind of prediction that is already present here. So given the parameters that we can see on the screen, it predicted the house of a particular building in US. And then the link is also here in the slide. Hello, can you hear me?
Search for them will be Emmanuel Indahimana. Emmanuel. Hello, Emmanuel. Are you there?
Okay. Okay. I was on mute. Sorry, then. Hello, can you all see my screen? Can you see my screen? Please confirm if you can. Hello?
Yes, I can.
Okay. This is Emmanuel Ndahima, and I'm from Group 10 in the presentation, and we are doing a temperature and humidity prediction. So in this open source project introduction, our problem is to use humidity to predict the temperature. So the data set we have there they contains several features, including wind pressure, wind speed, and the crowd level. But in this specific problem, it was to build a simple linear regression model to predict the temperature based on the humidity data set. So we first start doing some exposure data analysis, and where we deal with the missing variable, distribution of each feature, correlation according to our target feature, which is temperature, of course. So here, because of we are using only temperature as our predictor, so we start viewing the correlation between our target feature and our predictor, and they have a strong negative correlation. So we step ahead and doing some machine learning algorithm, but before we perform some machine learning, we start doing some data pre-processing. So we standardize our data sets to be able our algorithm to understand the structure of our data, and we build some model before, and we separated data from training to testing to test set to evaluate the performance of our model. And because of we didn't use that pipeline you recommended, because I used this IBM Cloud platform which has AutoML pipelines where you can build your the machine learning model, and at the end deploy to the cloud, and you can be able to test it by giving it in input as predictors input, and you'll be able to predict easily. So this is how this IBM works, and this is what I have used, and this image was from my data set. And then at the end, I found that a simple linear regression model performed well with the root mean square error of 7.44 and the R square of 0.39. So our our summary is that most of our predictors we have, they have very weak correlation between our target column, which is temperature, and our model, because we tried several models, including a random forest. Our models were predicting almost the same. So thank you so much. For any question, you are welcome.
Okay, thank you, Emmanuel. That was one. So we'll move on now to our judges.
Thanks. So we've right. This project is just to find the correlation between temperature and humidity.
Yes.
Are there any use case for this?
Which user case?
Yeah, like what can it be used for? Why, for example, as a user or as a user, a scientist or whatever, like why would I want to use it?
Yeah, sure. Yes, sure. Because we need to use this model to predict well the temperature. Because only people, they predict temperature using temperature itself, and they took it only as time series data set. So now it is another approach that you can predict temperature using some dependent features, including humidity as well.
Oh, sorry? You said you use regression models. What models?
Yes, yes. Mm-hmm.
So you just use a simple regression model. Did you do anything else to improve it?
No.
Oh,
it was that.
Okay, all right, sure. Thank you.
Thank you.
Okay, thank you, Ali. Building Charles.
Yeah, so some of the things that you might want to consider is just think about in temperature, humidity. What are like other variables that you can add to your data sets that would make it be more interesting? It might be an interesting topic for you, but how do you make it an interesting topic for broader people? Like, if you add region as an example, say we're using this data and this data is specific to a country, you can say, hey, in the southern part, this is what this means. From everything that I've heard from your presentation, I'm not seeing that spark that would light up an interest. Oh, I learned something new. So I had that to your presentation and your modeling. Start with the why. Why am I doing this?
Yeah, sure. Very good point. Very good point. Because to predict where this regression model, it will be making more sense when it's become multiple regression model, so that you can add more features to predict temperature. So we have wind speed, we have cloud level. There are many, but when we throw, like I said here on this slide, on this pandas profiling output to see some EDA, the correlation of those features to the temperature, they are very weak. They have weak correlation with our target feature. So that's why I say they can increase the complexity of the model, but they won't really contribute well to the model.
Yeah. And that's good. I mean, I'm glad you found that out. Sometimes you should think about the end from the beginning. Do more of finding the right data set. If maybe you don't have the right data set, maybe your data set needs a bit more work. So yeah, that's what I would say. Whenever you're starting any project, and this goes to everyone, think about how does it apply? How can my work be seen as valuable? How am I contributing to the society? How can someone else take my work and want to act on it? So, but yeah,
that's
good work, good trial, and yeah, looking forward to what you do next.
Yeah, thank you so much.
Okay, thank you, Emmanuel. Thank you for that presentation. Move over to the next group. Yeah, that's group 16, fake news. And the representative of that group is Olasumbo Banjoku. and Adu Anuluwapo.
Ndabona mbirangije hano batipe kumara mwuka. Sikana bikoresho kugira ngo barangirize.
Olasumbo Banjoku. Okay, I think Adu Anuluwapo is here. So please proceed.
Good day. Can you hear me?
Yes, good day. I know we can hear you and can see your screen. Please proceed. 2 minutes.
Okay. Thank you. This is group 16, and we worked on the development of an algorithm for fake news classifier using NLP due to the fact that authenticity of news is highly questionable nowadays. Our approach: data uploading and wrangling, data visualization, feature extraction, lemmatization, model selection, and accuracy measures. We cleaned and made 2 data sets, true news and fake news, and we created EA and 1 column from date. Data visualization. We checked for the news subjects that were related to the individual news type, fake and true news. True news have only 2 subjects, while fake news have 6 different subjects. We discovered that both fake and true news share a similar subject, which is politics and political news and politics news. Dates for fake news were steady from the first month to the 12th month. For the true news, dates were steady up to the 8th month. Years for fake news range from 2015 to 2018, and for true news, years are between 2016 and 2017. Then we viewed most common words based on the text and title columns of both news types. My colleague Olasumbo will explain the model in the next minute. Olasumbo, is you there?
Yeah, sure. Okay, so hello.
Yes, we can hear you, Sumbo.
So I had to do 2 methods to get meaningful insights from the machine learning work. So I had to take it by 2 approaches. First, the ML approach, which is called the automatic approach, and the second approach, which is called
you have 30 more seconds,
mining.
Sumbo.
Called text mining. So I applied tokenization, the process of reducing the text to words, and that was my first preprocessing. And then I removed stock words, punctuation, and in an effort to make meaningful insights on it, I had to do this analysis. So the next slide. I found out that words like be, in, prepositions, conjunctions were very frequent in the article that we were examining. So I had to remove those words, and you could see that the Pareto chart showed that D had about 80% of the data having words containing D, and then I worked on like removing them from my data. So I had the meaningful data, like words like President Trump, and then things like that. So the next slide. We had a precision.
Just round up in 10 seconds. Thank you.
Yeah, so we had a precision of about 0.99. Like virtually all the models we used were good, but the most useful variables or useful variables were logistic regression and HBM, not surprisingly, because when you're doing unbalanced sets, logistic regression is typically the one you go for, then SVM. The next slide. So in summary, we had...
Thank you. Thank you. Sorry, I'm about to cut you. Sorry.
Yeah.
Our judge is now, please.
Okay, so it looks like the data that you guys are using, they're too good, because I could see that you have like a 99% accuracy. Did you try to validate this on some other data set?
Basically, I had to validate it using the other method, which is text mining, which if you go to the slide of stemming, yeah, the stemming slide, you would see that, yes, that the first intuition was I had to use the stemming to get some aggregate information, like how relevant is this information. So the first value, which is about negative 0.05, tells us that the news is actually fake. Yeah, so it's not surprising why it has a negative. The first news is actually fake. And then the second one, which is 0.5, tells us how relevant it is. Is the data or the text we have, is it more balanced or imbalanced? That's in the sense, I mean, do you have more facts or more opinions stated in the article or in your text? So if it's very balanced, it will be around 0.5. If it's not balanced, it will be pushed to one direction, say 0.2, 0.8. So we see that it actually works. The data in actual fact works. So this is what I use as my analysis checker.
Oh, okay. All right, sure. Thanks.
Would there be any more questions?
Hold on, I think Charles has something to
Oh,
say.
yeah. I was going to ask. It said logistic regression in this case was a lot more better than SVM, which is like, I mean, I've experienced that before with some classification stuff. But can you explain? Did you do like a comparison between the two models and to validate this, or is this something that you just picked up based on intuition?
Well, basically, I've been working with machine learning from my master's, so I've had like some experience with it. So typically, you would go with the scores that has the highest accuracy. Please, could you go to the last slide, Anu? To the last slide. Typically, you would go with the one that has the highest accuracy, but I'd rather go with the one that has the better F score. And so from the F score that I had, this was closer to 999, and for me, it like reinstates the fact that sometimes logistic regression is the one you want to bet on. I mean, there are more statistical models like Probit and Logit, which people are working on to get inferential statistics on how it can be used for machine learning. But for me, I'd go with the bet. That's my intuition behind it.
Okay, cool.
I have one question for you. So,
yeah, sure.
Were you able to analyze specific patterns or trends with fake news? Something to think about. Like, were you able to analyze that? Oh, on Mondays you have more fake news, or this month there were more fake news based on your data?
Okay, so basically I had my visualization partner, Anu, do this part. So I think she'll be well, how to put the word for it, she'll be well elaborate with what she did in that section.
Well, I did not analyze the days of the week, but I analyzed by month and year. Yes. So,
And can you explain your summary to me?
okay, so for fake sorry.
The presentation looks blurry to me, and I don't know if that's the same for everyone. So,
it's blurry. Yeah.
But don't worry about it. If you can explain it, that's all that matters.
Okay, so date for fake news was steady from the first month up to the 12th month. That is from January to December, and the total number of news for each month ranged between 16 and a little over 2,000. For true news, the count for each month up to the 8th month, that is August, was a little below and above 1,000. And by the 9th month, total number of news per month increased to over 3,000. Then in December, number of true news dropped again. The true news subject that resulted in the shoot up was world news. And for the year, for fake news, the years range from 2015 to 2018. And for true news, the years was between 2016 and 2017. Altogether, the year with the highest number of news is 2017.
Okay, so
yeah.
Here's one of my suggestions to your team. When you have data sets like this, beyond analyzing the data and showing your data science prowess, you need to be able to start out your presentation saying, "Oh, guys, did you know that December has the highest amount of fake news?" Or do you know that since our data set started from this year, and did you know that fake news has increased from this point to this point? You engage your audience when you do that. I know this is the data science cohort, but most importantly, you should find ways to engage your audience without going too deep in the technical, and let the judges ask you the technical side.
Okay, thank you.
Thank
Well,
you.
we're just trying to beat time.
No, I understand, but
Yeah.
drop those killer punchlines so people would be engaged. They'll say, "Oh, I want to know more."
All right, thank you.
All right.
Thank you.
Okay, so thank you, Sumbo. Thank you, Anu. Thank you to our judges. We'll take the last group for the evening, and that's mental health. So the representatives of that group is Solomon Igori and Uthman Tijani.
Good evening.
Good evening, Solomon. We can see your screen. We can hear you. You have 2 minutes.
All right. According to WHO, depression and anxiety alone causes the global economy approximately $1 trillion annually due to loss in productivity. This is the mental health team, and we analyze data from the open source mental survey. The problem is the impact of mental health in technology workspace. Its consequences, not just for the individual alone, but also for businesses. There are existing solutions, but we're proposing the use of data science and machine learning techniques to determine the strong predictors of mental health illness, how its frequency varies, build a predictive model, and then give recommendations. The data set has 27 columns and 1,259 entries, and about 5.6% missing values. We clean the data, explore and visualize the data, build machine learning models, and evaluated the data, or the model, sorry. So from our analysis, about 60% of the respondents are from the United States. More than 50% of the participants has undergone some form of mental health treatment. 80% are males. Being self-employed has no influence on one's mental health. More than 80% of the respondents will not want to participate in a mental health interview. Mental health actually affects productivity, and there's no negative consequence discussing one's mental health, or usually no negative consequence.
30 more seconds.
Okay, discussing one's mental health with his employers. Okay, now when we're building the model, we did some feature encoding, splitting data, training data, and then evaluating the model. Okay, we trained a model with several machine learning algorithms, and XGBoost performed gave the highest accuracy with 80% accuracy. Okay, age, interference with work, and family history were the strongest predictor of one's mental health. This is a summary of our analysis. Thank you.
Thank you, Solomon. I was right on time. Now, our judges.
Can you maybe move it back to the summary section?
All right.
I mean, I'd like to start out by asking, so what were your major learnings? What were the first two things that you would say are the things that resonated with you the most?
I think this topic is what most employees actually, or most employees actually shy away from this topic, mental health, and it actually affects their productivity, so affects businesses. So my take home is people should start taking consideration into the mental health. Employees should start checking the mental health of the employees and looking for ways to improve the mental health of the employee, because it's going to boost productivity.
Okay. Right. And my next question is, so your data set says that you have 80% male.
Yeah.
That were part of the survey.
Yeah. It's not surprising because it's the technology space and it's male dominant.
Okay. Right. Well, yeah, I don't have anything to add other than the fact that yes, mental health is an important aspect, or is an important topic that a lot of people need to be aware of. Resting, making sure that you're talking to families and all, staying in a room every time is an important thing. So I don't know if Wale or Charles have anything to add.
Nothing from me. Yeah, good stuff.
Thank you.
Okay, I think Charles has something to say. 1 minute.
I'm good. Good stuff.
Thank you.
Okay, so thank you, Solomon. Let me use this medium as well to say thank you to you, Charles, to you, Wale, and to you, Bjorn. I think today has been quite eventful, and it's been a great event, really. So before I call in Femi to give some remarks, I think we need to listen to some recommendations, to some maybe pat on the back and maybe corrections so that our interns can improve from where they are already to the next level. So I think let me start with Jordan.
So overall, I thought it was all good, very inspiring that you all are taking this project very serious, and I mean you can only go up from here. From a recommendations perspective, there are some folks who did live demos. While live demos are good, they could also be your pitfall. I like that there was only one person throughout all of the presentation that I saw that had a video that was slotted into your presentation. I like that approach better. I believe it was the guy who did some form of live demo. You have to wait and come back. What if it didn't work? How are you going to defend yourself? So try to use more videos or GIF images whenever you're doing presentations. I think it's very important. You are data scientists. You're learning how to run all of these models, but it's very important to focus more on the business value of your topic. And you should spend more time doing that. Ask the folks that you're working with, ask your fellow peers that, hey, what do you think about this topic? I particularly have learned that just talking to people gives you multiple dimensions as to how your topic can go. So talk more with your peers, talk more with your instructors, and have more ideas as to how your topic relates to the real world. And find a passion. If you're not passionate about the topic, you probably wouldn't be able to do more or be able to translate it into business sense. So the other part is scope down your issue as much as possible. There were so many like big topics, but if you say it's fake news with regards to what? Is it politics? Is it this? That way it helps people have a frame of mind as to where you're going. So scope down and spend more time doing research on your data sets. Like there are tons of data sets out there. I mean, you're already using Kaggle and there are tons of other data sets. Spend more time finding the right data set that matches what you're doing, because that way another group might take up your project and use that same data set and make more meaning out of it. If your data set is weak, chances are you're going to have to do everything you did again, all over again, especially if you're not getting actual data. So yeah, those are my recommendations.
Thank you, Bjorn. 3 points Bjorn raised. You can only go up from here. Talk more with people, find a passion. I think this is very insightful. Thank you, Bjorn, once again.
Yeah.
Okay, so Wale.
Well, if you're talking, you might be on mute.
What? Yeah.
Oh, okay. I think I'm on mute. Sorry. So some of these presentations were there were a lot of improvement from the last time, so that's good. One thing that I would mention is for the time, I actually think the time is good, the 2 minutes. And the reason is that, there are a lot of projects, but also in the business world, I'm sure Charles probably knows about this a lot. There's something called elevator pitch, where you have 2 to 3 minutes to say whatever you want to say. And it means that you have to be so just think of you being on an elevator with a Dangote, for example, and you want to explain your business to him or your startup, you probably have 2 or 3 minutes to convey everything. Like, what's the problem statement, the technique, you don't need to go deep into it, and more importantly, the value, which is one thing that Biodo mentioned. So for presentations like this, I think you have to prepare, which means you have to practice. And from some of the talks, it was very evident that a lot of people did not practice. I saw people with like 17 slides and they're trying to go through all the 17 slides before the moderator would say 10 seconds more. So practice is extremely important. Practice with someone, time yourself before you present, and that would actually help you with delivering a better presentation. The scope needs to be streamlined a lot. If you're working on something, just echoing what Bjorn said, you have to make sure that the scope, the value around your project, you amplify it much better. You streamline and also amplify it in the presentation. So that's also very important. And then the slides, I saw some slide transitions that I was like, oh no. I mean, it's a 2-3 minutes presentation. You don't need your slides to be flying out and flying in. You don't need it. So please, no more flying transitions. Yeah. Thanks, Femi.
Thank you, Wale. No more flying transition. I think that's a very important one. Prepare, practice, time yourself, focus on the value, the scope, and remember, elevator speech. So thank you very much, Wale. I think that was also very insightful. So we'll listen to Charles now.
Yeah, I think Bjorn and Wale said it all. They nailed it, so I don't think I have much to add. But just to add to what you guys are doing, a great job. And I mean, I see everything as a privilege. This is an opportunity for you to like showcase your skills. I know it takes a lot more work to get things to that level, and you're just given a chance to give like maybe a mini presentation of your work. But you don't want to look at it that way. Whatever you've done now, just see it as a beginning, and don't go back and relax. Just keep doubling up on your efforts and things like that. And a lot of the time, whatever you do, you only have a few minutes to create an impression. So that's why I was a little bit hard on some of you when you're presenting your work. The quality matters because people will always go with the impression they have of you. Like, I don't know how many hours you guys put into this or how many days, but the only thing I know is like at the moment I want to be carried away by what you're doing. I mean, that creates an impression, and it's that impression that you want to take over to whatever you're doing, whatever you're working on. It's kind of like your brand and things like that. So my suggestion for you guys is like, let this be the beginning, don't let it be the end. Just keep doubling up on the effort. It's going to pay off at some point. The quality of your presentation matters. Wally was saying something about elevator pitch. You're going to run into different people along your career path, and you just want to make that quick 5 seconds or 10 seconds impression that takes you to the next level. So also put a lot more attention on the quality of your presentation at the end of the day, and go back and do more research. Some of you are new to this and you're trying to put things together. You're trying to like do a presentation, but the ultimate goal of this is to be able to be skilled enough so that you can build your career around this, build products that could scale and sell to like tens of millions of people. And to do that is not a very easy task. So make sure you understand what you're actually doing, a deep understanding. I think it's very important. So focus a lot of energy on that. And it's not going to pay off right away, but I promise you guys, if you stay with it, months from now, years from now, you'll always remember this day when you got started. Kind of like every one of us out here. So I'll say, put more energy into it. You guys are on the right path. And it's a good privilege to be involved in this on my part and on your part. And I think we're up to something great together. Thank you.
Thank you, Charles. See this as a privilege. A lot more work needs to be done. See it as a beginning. Quality matters. I think today has been quite a wonderful one, and putting together everything that we've learned. I'm sure our interns are on a different level from where they were in the beginning. Okay, so okay, Wale is saying we should write blog posts about the project. Yes, our query analysts for each group have written articles about this project, and in a short while it will be published on Medium. Meanwhile, I just want to thank each and every one of us for being here. I want to especially thank Wale, Biodu, and Charles. I think it is more than a privilege. For lack of a better word, let me say it's a privilege to have you on this platform. So I will hand over now to Femi Uyenowo, who will give us a few closing remarks, and then we can go.
No. So, as Mara rightly said, it's a privilege to have you, Charles, Biodu, and Wally here today. And the interns definitely agree, as they've basked in your innumerable experience and invaluable experience so far, as you've been able to pinpoint the areas they need to improve on. And I'm sure, as Emmanuel has rightly said, their level of understanding and the level they were on before the presentation is not what they are on now. They've been able to learn a lot. So I want to say thank you for sharing that with us. And for the interns, I must say it's been a wonderful presentation from each and every one of you. With the time constraint, 2 minutes, and the quality of presentations that were put up, and despite everything, I would say kudos to each and every one of you. You always have a pat on the back. And as our judges have rightly put, all that's been said today is to make sure that you go from one level to another, and so you can able to reach the highest peak. Do you understand? So it's all that's given today, all the feedback that's been given. We implore you to please take this feedback home, work on them, as they'll be pivotal in your moving forward. There's a popular quote that says, it says, if I'm able to see far, it's because I stood on the shoulder of giants. So if you want to see far, if you want to go far, it's by standing on the experiences and the feedbacks of our judges today. So thank you, everyone. And we've come to the end of the stage F open source presentations. And I would like to say thank you to everyone for joining. And we look forward to seeing what you do later in future. Thank you very much, everyone. Thank you, Charles. Thank you, Biodu. Thank you, Ali. Thank you to all the interns. God bless. Take care. Bye for now.